Hello, this is Kai from Raising the Bar, and in this video I want to show you how to simulate a coin in Excel. In my book, this is exercise 2.1. In general, Excel is a very powerful package because you can use in Excel a programming environment called Visual Basic, and actually Visual Basic is available everywhere in Microsoft Office. What we're going to do is very simple, and I want to show you simulation of the coin, or which is called scientifically Bernoulli variable, in two steps. The first step is this: how can we generate a variable which is uniformly distributed over the segment 0, 1? The command is this, that you have to start with the equation sign and then random with empty parentheses, okay? And you can see here the random value generated by that command. And then each time you change anything in the spreadsheet, like I type here 1, that value of the random variable can be recalculated, and you can choose the calculation options on the ribbon. You go to the tab called Formulas, and then in Calculation Options, you can choose either automatic or manual. I chose manual. So with this choice, I can press F9 to cause recalculation. Here, see, I'm pressing F9. You don't see how I'm pressing it, but I put here also a button on the quick access toolbar, Calculate F9. So I'm pressing it, and you see random numbers between 0 and 1, and each of those numbers is equally likely. This is why we say that this is a uniform distribution. So this is the first command that we need. The second command that we need is called if. In order to see the format of command, we can insert the command and see the format of command. We can press this button for inserting functions, and I already have here, it is called if. Or if you don't have it here ready in the lower window, then you can go to the category and then select logical. This command is available among logical commands, okay? And then you can see the format of the command. The first argument is the test that you want this command to check, and the second argument is the value that the command should provide if the test passes. And the third argument is the value that you want to provide that if the test does not pass, okay? So here I say okay, okay? And then the first command will be that the value of the random variable that we used in the first step. And we want to check if this value is larger than, say, 0.5. 0.5 corresponds to a fair coin. So if this is true, then the value supplied should be equal to 1. If this is wrong, the value supplied should be equal to 0 here. And then say OK. Okay, so right now you can see 0, and this value is random. Now see what happens if I press F9. Okay, that the generated value is changes. Sometimes it is 0, sometimes it is 1, and over the long run, if you generate many such values, you will find out that the ratio of 0s to 1s is approximately 50-50. Here, instead of that command, I want to put the name of the variable that we generated. We generated a coin, okay? The scientific name for the coin is Bernoulli. Now, with the values that we have here, I put here 0.5, okay? If it is 0.5, then this will be a fair coin. If I change it to something else, like 0.3, for example, it will be an unfair coin. here's an unfair coin, and in this case you will see that 1 appears more often than 0. Okay, here I am pressing F9. Okay, this you see, you cannot hear how I press it. Okay, let me press here. I press, and several times in a row it was 1. Press, okay, so you can see that 1 appears more often than 0. Okay, so now I want to use this opportunity to explain the general format in which we write discrete random variables. Like, there should be it should be a table with 2 columns. One column for the values of the variable. We call the variable C for coin, and here we put the corresponding probabilities. And coin takes 2 values. One with probability that we assign P, and 0 with probability 1 minus P. 1 minus P because the sum of the 2 probabilities should be equal to 1. So here, this table describes a general Bernoulli variable. Now, what we have here in the first row of the table is a shortcut for this statement. Probability that C equals 1 equals P. Okay, and similarly, the second line of the table means that the probability that coin takes value equal to 0 is equal to 1 minus P. Okay, this is all for today. Thank you.